For decades, heavy armor rolling across the plains defined the image of Russian military power. Today, a small, agile drone shadowing a 40-ton tank represents the real center of gravity on the battlefield. Before we explore how this shift happened, take a second to subscribe to the channel so you don't miss our future deep dives into modern military strategy. Going back to the early 2000s, the Russian command and control structure looked very much like it did in the Soviet era. Orders were primarily paper-bound, and combat relied on massive columns of troops supported by an overwhelming barrage of grid-clearing artillery fire. Russian military strategists recognized that this brute force approach was expiring. They began preparing for a transition they called the Revolution in Military Affairs, or sixth-generation warfare. This doctrine argued that the era of massed hardware was over. Future conflicts would be determined by information dominance, relying on highly advanced sensors, integrated electronic warfare networks, and precision smart munitions to systematically dismantle an opponent. The entire objective of this theory comes down to one metric: speed. In a digitized battlespace, the side that collects, processes, and acts on target data the fastest dictates the outcome of the fight. On paper, the Russian General Staff recognized they needed to fight a network-centric war. The digital infrastructure connecting their platforms was now intended to function as the primary weapon. To execute this theory, Russia attempted to build a massive, top-down digital command architecture. They wanted a flawless, automated system that connected every single sensor and weapon platform into one screen for senior commanders. This is the Russian National Defense Management Center, the ultimate expression of that vision. It is a high-tech facility built for high-level oversight, but an architecture designed to funnel data all the way up to a general in Moscow often sacrifices tactical agility on the ground. While state-owned software integration lagged, Russia successfully modernized its physical hardware through a layered integrated air defense system. This is the S-400 Triumf. It serves as the long-range strategic node of this physical defense network, capable of tracking and engaging high-value targets at vast distances to provide wide-area situational awareness. To protect advancing ground forces, they rely on the medium-range Buk M3 surface-to-air missile system, designed to keep pace over rough terrain. Protecting those larger assets from localized threats is the short-range point defense layer. This is the wheeled Pantsir S-1, equipped with missiles and anti-aircraft cannons. These layered physical defenses were highly capable, but high-intensity combat in Ukraine exposed a flaw in the broader command network. The grand, top-down automated systems built over the previous decade were simply too slow. In a traditional hierarchical command, a forward observer spots a target and sends the data up through multiple levels of command to task an artillery battery. By the time the approval makes its way back down the chain, the fast-moving target has already relocated. The quest for an elegant, all-seeing, centralized system created a bottleneck. Under the heavy friction of real-world combat, centralization became a severe liability. Faced with these failures, the Russian military pivoted. They stepped away from slow state defense companies and began utilizing civilian technologies and volunteer software developers to solve immediate battlefield problems. The immediate tactical need was reconnaissance and rapid engagement. To solve this, operational control shifted heavily toward unmanned aerial systems. As you can see with this gray UAV mid-flight, drones are now the primary tool for battlefield management. In fact, up to 80% of current Russian fire missions are now conducted using unmanned systems. This shift forced a redefined approach to artificial intelligence. Rather than trying to build AI that makes strategic decisions for generals, the military treats AI strictly as a tactical support tool. Developers began taking open-source AI models and adapting them for the battlefield. They integrated computer vision and sensor fusion into scrappy, task-specific software suites, like the GLAWS and GROZA systems. This schematic shows how that tactical software actually operates. The drone's optics detect the target, the AI processes the visual data, and the software routes the coordinates directly to the firing unit. The top-down interference is completely bypassed. This creates a massive acceleration in the strike process. By cutting out the rigid hierarchy, the software compresses a process that used to take hours into just a few minutes. By sacrificing centralized oversight, Russia successfully closed the time gap between detection and impact. The original vision of the revolution in military affairs, a pristine, fully automated battlefield managed by flawless digital networks, never arrived. The current reality is far more pragmatic. It is a fragmented ecosystem built on rapid, on-the-ground adaptation using commercial parts and volunteer-coded software. Speed in the kill chain, the time it takes to spot a target and destroy it, matters far more than maintaining an elegant, unified network. Modern military innovation often prioritizes ruthlessly adapting available civilian technology over inventing entirely new physics. Ultimately, the true shape of warfare is dictated by the friction of combat. It mercilessly strips away grand peacetime theories, leaving behind only what actually works to survive. Thanks for watching.